Okay, so here's a question that we need to solve today. We have an integral which says sine of x to the power n divided by sine of n, sine of x power n plus cos of x power n. And we have to integrate this from 0 to pi by 2, right? Now, it seems a little intimidating if we start looking at it, okay? But there are rather simpler ways to solve it. So let's see how do I go about solving this integral. So the moment I see sine x and cos x, I think about substituting it, right? So that I know cos and sine are related to each other, so maybe I can express one as a function of other. So let's try if that method works, okay? So I'm going to use substitution here. So let's assume that t equal to sine of x. So if t is sine of x, this also means that cos of x is root under 1 minus t square, right? Because sine square x plus cos square x is 1. And then my integral then becomes, so at x equal to 0, t equal to sine of 0, which is 0. And at x equal to pi by 2, t becomes sine of pi by 2, which is 1. So then my original integral pi then becomes, instead of 0 to pi by 2, I'll integrate it over t, not x anymore. So it becomes 0 to 1. And then there is something which will come here. And then there is dt. Now, how do I express dt as a function of dx? So I do it same differentiation here. So t is sine x. So dt is cos of x dx, right? Which is basically 1 minus root over t square of dt. Okay. So I'm sorry, I should write this as 1 minus t square of dx, right? So which basically means I can write dx as dt over 1 minus root of t square. So that means I need to add 1 minus t square to the power half. This is just representing the dx piece of it, right? So my dx here is represented by this whole thing here, right? Now I have to write the other pieces here, the numerator of sine n power x. So I know my e is sine x. So sine n power x simply becomes t power n. And then I have t power n again, plus cos x is 1 minus t square to the power half. And then it's cos nx. So I can simply write it n by 2. And then this whole thing is multiplied by what I wrote earlier, right? So let me remove this piece here. So this is the integral. So essentially, this is my integral. Now, does it seem like an integral that I can solve? Although I converted sine to t and cos to t, but still remains quite complicated, and I can't think of an easy way to solve this integral. So I just showed you this to sort of demonstrate that even though it seemed like a substitution problem, it wasn't that easy to substitute it, right? So let's try something else now and see if that works. So let me draw a line here so that I can try an alternative method. Okay, so now I'm going to use a property which is called f of x dx when integrated from 0 to a is equal to f of a minus x dx 0 to a. Now, why is that? It's essentially just converting, or not converting, it's kind of taking a mirror image of the original function. So let me show you that little graphically so that I can prove this formula that I have written here, right? So let me do that. So let me draw it graphically. So this is x. And let's say this is my y equal to f of x, right? I just took a random function. And let's say that this here is a, and this of course is 0. So then I can conclude that the integral, this integral here is same as this area here, right? So this essentially is I equal to 0 to a f of x dx. Now let's see what f of a minus x is, right? So if I know y equal to fx, if I know the graph of this, I can always tell that the graph of y of f of minus x is nothing but a mirror image of the graph y equal to fx about the y-axis, right? So if I may draw that, so it will be kind of like this, right? Although I didn't draw it very well, but if I could have extended this a little, it is a here, right? So this is the graph of y equal to f of minus x, which is just a mirror image of y of f equal to x. Now, what is y of f of a minus x? So once again, without going into too much of details, but it's intuitive that if I have the curve of y of fx, or y of f of minus x in this case, if I have to add a to x, all I need to do is to sift the graph, right, by a. So I know this part is a, this whole thing here kind of comes here, okay? So this becomes y of a minus x. Okay, so any point, so I have just translated this point by a distance of a, and which is, as you can see, it's 0 to a here, 0 to a here. So this graph, well, once again, I did not draw it very well, but then this integral here, okay, is also same as, once again, 0 to a. But what is my function here? It's f of a minus x of dx, right? And I'm claiming these two are equal because it's the same curve. First, I took a mirror image of the curve, and then I sifted the curve. And then it's the same shape, same curvature, everything is same, and even the points that bind the curve are the same. So now instead of fx, I'm going to look at f of a minus x. So now going back to my original integral, wherein what was the integral? I'm going to write it out again. Changing to blue ink now. So it was 0 to pi by 2 sine of nx by sine nx plus cos of nx dx, right? Now, let's use this formula that I just used earlier. So what is fx in this case? This whole thing that's being integrated. So now let's say fx is sine of nx by sine of nx plus cos of nx. Now I'm going to use this formula here. Now the question comes, what should my a be here, right? So a is nothing but pi by 2. So let's see if I say f of pi by 2 minus x, right? A is equal to pi by 2. What does it become? Sine of pi by 2 minus x. We know sine and cos, they are complementary to each other. So sine of pi minus 2 by x will always be cos of x. And then the whole thing is power to n. So this thing then becomes cos of n power x. And then the same thing happens in the bottom as well. So this becomes sine of pi minus 2 by x, which then becomes cos of nx. And this one now becomes sine. Okay. Now, I just said earlier that I is 0 to pi by 2 fx dx, and it is also equal to 0 to pi by 2 f of pi by 2 minus x dx, right? So I can in effect say that I can replace this guy here with this here, right? And I can replace this with this, right? So let's do that. So I can say I, and now I'm going to do something interesting. Instead of putting equal to, I'm going to add both of this. So this is also I, and this is also I. So if I add both of them, they become 2I, right? Now instead of first I, I'm going to write this one, which is sine of nx by sine of nx plus cos of nx dx 0 to pi by 2 plus 0 to pi by 2 once again, this time of cos of nx plus cos of nx plus sine of nx dx. Now you see what's happening here? The denominator is the same. And if a definite integral is such that the limits are the same, I can actually sum them over. So this becomes 0 to pi by 2, and then I take the common denominator, which is sine of nx plus cos of nx dx. And what's happening in the numerator? This is sine of nx plus cos of nx. Wow, what happened now? The numerator and denominator are the same. So all of this just cancels out, right? So this simply becomes 0 to pi by 2 dx, which is nothing but x, and the value of x from 0 to pi by 2, which is nothing but pi by 2 minus 0 equal to pi by 2. Okay, so now I have 2I equal to pi by 2, which I can conclude as I is pi by 4. This is my final answer. Okay, so although this seemed a little intimidating in the beginning and I tried substituting, but the idea is we don't have to jump into substituting everything right away. Sometimes looking at alternative methods like the ones that we just saw can be helpful. So this was a